Hi and Assalamualaikum everyone. My name is Yohanis Damia Danila binti Nurzad Dizul. My matric numbers is 2025126151.
Hi and Assalamualaikum everyone. My name is Hasha Umairah binti Muhammad Asrizal and my matrix number is 2025379769.
Hi and Assalamualaikum to everyone. My name is Nur Shami Anisa binti Salali and my matric number is 2025305469.
Assalamualaikum everyone, my name is Nuriza Atira binti Ishaq and my matric number is 2025109361. Compound interest is interest accumulated from a principal sum and previously accumulated interest. Is it the result of reinvesting or returning interest that will otherwise be paid out or of the accumulation of debt from a borrower? Compound interest is contrasted with simple interest, where previously accumulated interest is not added to the principal amount of the current period. Compounded interest depends on the simple interest rate applied and the frequency at which the interest is compounded.
Problem statement 1. Bear received 1,000 ringgit from a financial reward program and decides to deposit it for 4 years into a MyBank to You fixed deposit account. The account offers an interest rate of 2.20% compounded quarterly.
Objective Case Study 1. First, to determine the accumulated amount at the end of the saving period. Second, to calculate the total interest received by Bell. Third, to calculate the account balance at the end of saving period if Bell makes an additional deposit of Rm 500 into the same account 2 years after her initial deposit. Fourth, to calculate the accumulated amount at the end of saving period if the interest rate changed to 2.45% compounded semi-annually 6 months after her initial deposit. Result and discussion. Case study 1. P equals to 1,000 ringgit. The interest rate, which is K, equals to 2.20% per annum, which is equivalent to 0.022. M equal to 4, T equal to 4 years, I equal to K over M equal to 0.022 over 4, so I equal to 0.0055. N equal to M multiplied with T equals to 4 multiplied with 4. So N equal to 16.
Objective 1. To determine the accumulated amount at the end of her saving period. S equal to P in bracket 1 plus I to the power of N. S equal to 1,000 in bracket 1 plus 11 over 2,000 to the power of 16. S equal to 1,091.72 cents.
Objective 2. To calculate the total interest received by Bell, we will use the formula I equal to S minus P. So I equal to 1,091 ringgit and 72 cents minus 1,000. So the total interest that received by Bell is 91 ringgit and 72 cents.
To calculate the account balance at the end of saving period if Bell make an additional deposit of Rm 500 into the same account 2 years after her initial deposit. Let's have a timeline. For P1 equals to Rm 1000, P2 equals to Rm 500, and S equals to what Rm? For T1 equals to 4 years, T2 equals to 2 years, and K equals to 2.20% in bracket 0.022. M equals to 4, and I equal to K over M equal to 0.022 over 4 equal to 11 over 2,000. For N1 equal to MT1 equal to 4 multiplied 4 equal to 16. Next, N2 equals to MT2 equals to 4 multiplied 2 equals to 8. S1 equal to P1 in bracket 1 plus I to the power of N1. S1 equal to 1000 in bracket 1 plus 11 over 2000 to the power of 16. S1 equal to Rm 1091 ringgit 72 cent. Next, P new equal to S1 plus P2. P new equals to 1091.72 plus 500. P new equal to Rm 1591 ringgit 72 cent. S equal to P new in bracket 1 plus I to the power of N2. S equal to 1591.72 in bracket 1 plus 11 over 2000 to the power of 8. S equal to Rm 1663 ringgits 12 cents.
Objective 4. To calculate the accumulated amount at the end of saving period if the 2.45% compounded semi-annually 6 months after her initial deposit. We have K1 equal 2.20% in bracket 0.022 in bracket. M1 equal 4. I1 equal K1 over M1 equal 0.022 over 4 equal 11 over 2000. N1 equal M1 multiply T1 equal 4 multiply 4 equal 16. K2 equal 2.45% in bracket 0.0245 in bracket. M2 equal 2. I2 equal K2 over M2 equal 0.0245 over 2 equal 0.01225. N2 equal M2 multiply T2 equal 2 multiply 0.5 equal 1. S1 equal P in bracket P plus I1 to the power N1. S1 equal 1000 in bracket 1 plus 11 over 200 to the power 16. S1 equal 1091 ringgit 72 cent. S equal S1 in bracket 1 plus I2 to the power N2. S equal 1091 ringgit 72 cent in bracket 1 plus 0.01225 to the power 1. S equal 1105 ringgit 9 cent.
Case study 2, annuity. An annuity is a series of equal payments made at regular intervals over a fixed period of time, such as monthly or annually. In business mathematics, annuities are used to calculate future savings, loan repayments, investment, and retirement plans. There are two main types of annuities: ordinary annuity, payments made at the end of each period, and annuity due, payments made at the beginning of each period. Understanding annuities helps individuals and businesses manage their finances effectively and plan for long-term financial goals.
Problem statement 2. Mr. Michael are considering purchasing a Honda Jazz priced at $52,900 with a 10% down payment. The remaining balance to be financed through a loan from Car Loan. The bank offers an interest rate of 4% compounded monthly and is to be repaid over 6 years.
Objective 1. To determine the monthly payment amount required to repay the loan over the 6-year period. Objective 2. To calculate the total interest incurred by Mr. Michael. Objective 3. To calculate the outstanding loan balance if Mr. Michael decides to settle the loan earlier than scheduled after paying the 55th payment. Objective 4. To determine the outstanding arrears that must be settled on the next payment if Mr. Michael meets the 3 consecutive monthly payments. Result and discussion. There's our timeline. A equal to Rm 47,610. R equal to what Rm? Cost price CP equal to Rm 52,900. Down payment DP equal to 10%. Multiply CP equal to Rm 5,290. Balance B equal to CP minus DP equal to Rm 47,610. K equal to 4% in bracket 0.04. M equal to 12 bi-monthly. T equal to 6 years. I equal to K over M equal to 0.04 over 12 equal to 1 over 300. N equal to MT equal to 12 multiplied 6 equal to 72.
Objective 1. To determine the monthly payment amount required to repay the loan over the 6-year period. A equals to R in bracket 1 minus in bracket 1 plus I to the power of negative n over I. R equals to AI over in bracket 1 minus in bracket 1 plus I to the power of negative n. R equals to 47,610 in bracket 1 over 300 divide in bracket 1 minus in bracket 1 plus 1 over 300 to the power of negative 72. R equals to 744.87 cents.
Objective 2. To calculate the total interest incurred by Mr. Michel over the loan period, we will use the formula interest equal to the total amount paid R multiplied by N minus the loan amount A. Substituting the values, interest equals to 744 ringgit and 87 cents times 72 minus 47,610 ringgit. So total interest is equals to 6,020 ringgit and 64 cents.
To calculate the outstanding loan balance if Mr. Michael decides to settle the loan earlier than scheduled after paying the 55th payment. N unpaid equal to N total minus N paid equal to 72 minus 55 equal to 17. AN equal to R in bracket 1 minus in bracket 1 plus I to the power of negative n over I. A20 equal to 744.87 in bracket 1 minus in bracket 1 plus 1 over 300 to the power of negative 17. Final answer, A20 equal to Rm 12,290 ringgit 79 cents.
Objective 4. To determine the outstanding area that must be settled on the next payment if Mr. Michael missed the 3 consecutive monthly payment. N unpaid equal 3 plus 1. N unpaid equal 4. Sn equal R in bracket 1 plus I to the power n minus 1 over I. S4 equal 744 ringgit 87 cent in bracket 1 plus 1 over 300 to the power 4 minus 1 over 1 over 300. S4 equal 2,994 ringgit 41 cent. In conclusion, understanding compound interest and annuity is crucial for effective long-term financing planning. Compound interest, the interest in both principal and accumulated interest. Also, one of the key insights about compound interest is that is it a long-term strategy. By starting early and consistent investing over time, individuals can benefit from the power of compounding. This means that even small contribution can grow significantly over time as interest is earned. Annuity characteristics is payments are made at the end of the payment interval and the payment of compounding frequency are equal.